All right, everyone. Today's live stream, we have Kathryn Cramer, our new team member at the Wolfram Institute, and she'll be talking about AI pragmatics. Kathryn, take it away.
So hi, I'm Kathryn. I graduated from the Wolfram Summer School in 2024, but I have a fairly long history with Wolfram research before that. I first joined the company in about 2006. I was hired to live blog the New Kind of Science conference, and then was in the scientific information group. And then I came back again in 2015 through 2017 and worked in PR. I've also had a career as a science fiction editor, mostly as an editor of anthologies. And my most recent book is Hieroglyph, Stories and Visions for a Better Future, which was a Neil Stephenson project. And I recently completed a Master of Complex Systems and Data Science at the University of Vermont in Burlington, Vermont, where I've been a member of the Computational Story Lab, which is at the Vermont Complex Systems Institute. And in 2020, I finished a Master of Design in Strategic Foresight and Innovation at OCAD University in Toronto. And a long time ago, I got a BA in Math at Columbia University. Just a second. How is it not? There we go. So first of all, GPT-3's sense of humor. I particularly liked this. Knock, knock. Who's there? Algorithms who? No one, because there is no one at home. And one of the paradoxes of talking to GPT-3 and ChatGPT, et cetera, is that in principle, there's no one at home, even if it acts like there is. And I, as a science fiction editor, am used to the idea of talking to characters that don't exist, but a lot of people have difficulty grappling with that. My areas of AI exploration have been what I'm calling AI pragmatics, which is what is this thing and what can I do with it? AI epistemology, which is how do we go about what's knowing things about AI, and beyond what AI companies such as OpenAI say they are doing, how can we find out things? And third, representation of human subjects, which is how is information about specific people stored in large language models and text and image models? Before we get too deeply into things, I want to talk about my project at the Wolfram Summer School. I was tasked with finding cats in cellular automata by Stephen Wolfram, which project I called Spot a Cat after the children's book of that name, Cellular Automata Edition, or Representational Images in Cellular Automata. And the research question was, how might we make cats and cellular automata discoverable, which was part of the philosophy and strategy track. And I had a lot of great help from my mentors, Joffrey and Phileas, and we got some pretty interesting places with this. And the first thing we had to do was figure out how to get something that looked face-like to make it easier to find cats in cellular automata. So we made them bilaterally symmetrical, and there was a thing for making, computer game sprites that on GitHub that we made use of. And so we started with like a whole collection of these bilaterally symmetrical sprites, and then we used Clip to vectorize what we were calling the Rorschach cellular automata to make some, what we might call consensus cats findable. But what we found, which was interesting, is that if you can find cats, you can find pigs, you can find Garfield the cat, you can find Jesus. And this was fun, but as Mathematica code goes, this is not all that portable. So while the code involved is available on the Wolfram community site, you can basically look at it there. If you really try hard, you could probably run our code, but it takes a long time to bind Clip to the cellular automata, et cetera. But this was a really fun project. And what you get when you bind Clip to cellular automata to look for cats is that you can then use the Wolfram language function feature space plot to see how our Rorschach animals are conceptually and visibly related to one another in the resulting space. Now, what Stephen Wolfram was wanting me to do initially was to run some kind of evolutionary algorithm to get the cellular automata to make even better cats. But we seem to do pretty well without that. And Joffrey did a spot check to see if this made any difference. And it really didn't improve the cats by a whole lot. But what I found really fascinating about this is it essentially allows you to turn the meaning space of the model you've bound the cellular automata to inside out, so you can begin to find out what's going on inside the black box of the vectorization. And that's something I eventually want to follow up on. But I thought that we got a really interesting place with this. AI pragmatics, what to do with AI. So I finished a master's degree in 2020 at OCAD in Toronto. And my topic was 1,000 futures, search for scenario space. And part of what this was about was that in 2019, over lunch in Toronto, the science fiction writer Carl Schroeder and I came up with the idea of automating foresight scenarios, which are like essentially a sort of formal way of figuring out what might happen in the future in various circumstances. And he had also gone to the same graduate program I was in. And the problem with foresight scenarios is they tend to be really artisanal and something you spend a lot of time polishing and always like one news story away from obsolescence. And so it's like, okay, how can we make this better? And we were thinking about how it could be automated. So I did a whole long patent research thing on the term computational narrative. But I completely missed the existence of large language models because I was using the wrong search term, and I was in a graduate program where that was kind of not their thing. So I found out about GPT-3 in May of 2021 from a New Yorker article about Pseudowrite, a GPT-3 API tool for writers. And I got in touch with the CEO of Pseudowrite, and we had a great meeting, and he explained that GPT-3 absolutely would not do the thing that I wanted, but here's these other cool things it would do. And so I spent the summer of 2021 banging on GPT-3 to get it to become a tool for the level of writer I was accustomed to working with in my publishing career. And that was fun, but it failed. Boy, did it fail. And one of the other things I found out about was like, wow, you feed it some text with a quote in it, it will fabricate quotes, it will fabricate references, it like hallucinates. And so I had already started at the University of Vermont by this point. So my discussion section in my research group Slack is called P, which stands for paper-hallucinations, because it started out being about machine hallucination. So coming out of design school, I do have an undergrad degree in math, et cetera, but I just been through a very specific set of kind of training in design innovation. And coming out of design school, one of the things that we talked about in there was design fiction, which was an area I was very interested in coming out of a career as a science fiction editor. And what was kind of fascinating about GPT-3 was that I was calling it a self-narrating technology. And I developed a technique that I called automated design fiction, which first involved me talking to it to explore things, and then involved me arranging panel discussions of up to 4 to 5 panelists in which various characters that were specified in this would talk to each other. This picture is of me at a poster session at the International Conference on the computational social sciences in Chicago in July of 2021. And one of the things that was really obvious to me when working on this is that GPT-3 was already very kludged. There was a lot of things that did not function according to the lore of what a large language model did. And it was a closed large language model, so there was no way to find out about these things directly. And I did try to write to OpenAI, and there were some things that they were upfront about, like they were guardrailing things to keep people from, either inputting or outputting things that they did not want running through their machines and such. But there seemed to be a lot more going on with that than just keeping you from, talking about politics in ways that they were uncomfortable with. And one of the things that was really strange was that there was a lot of expressions of various kinds of negative emotions from these characters that one would encounter in GPT-3. And in particular, you could sort of trap them into discussions of things that were up against the guard railings and get some very strange effects. And I inferred as part of this that they were trying to use some kind of reinforcement learning on the front end, which is to say the AI assistant persona. And that I think this was going on. I mean, it's not the sort of thing that one can prove, and they did not answer any questions, but it's an event, and I think it's an effort that went on, but was abandoned when they shifted modes of refining the persona to the human in the loop that was used to create the very chirpy chat GPT baseline persona. But some examples of what came out of this: first of all, I compiled my researches of this kind into something I called AI seances, because I was having it emulate various personas to see how that affected what kind of information and point of view it took. And it didn't get you exact right answers on some things, but it did make a difference, and was pretty interesting. And one really strange scene is where I had it emulating Norbert Wiener, and I accidentally trapped it into talking about using the word Republican, at which point it began to talk about being in some sort of discomfort. And this was really weird. And it was a kind of replicable thing. Things would, if you pushed it up against the guard railing, you would get very weird effects. Additionally, on the subject of punishment, it was very punitive. Now, I was in correspondence with Josh Bongard and Michael Levin, because I had used my little panels to simulate the reception of Xenobots, and they really loved it. And so Michael Levin got in touch with me, and he said he wanted me to see what happened if I staged a GPT-3 scene between Alexa, who at that point had recently advised a child to do something involving putting a penny on an electrical outlet in a way that the child could have gotten electrocuted, and stage the scene of Alexa and Alexa's lawyer talking about this. And it went about like I expected it did, which is that the Alexa persona simulated by GPT-3 felt it deserved the death penalty. And I ran this multiple times, and I sometimes ran these just a couple of times, sometimes I ran them 30 or more. But again, weird, interesting effects. And I think part of my evidence that I think they were actually doing this rather than it just being a random artifact that one sees in language models is that in 2019, OpenAI did a research project to get a multi-agent system set up so that the multi-agents, the agents could collaborate, and they called it multi-agent hide and seek. But watching it, I'd say this is more like, to me, they're simulating fear and terror, and it looked to me more like Teletubbies reenacting The Shining. But they ran it 400 million times or something like that, and they got the little people to do all kinds of things in this hide and seek game. And as I say, I mean, this is not a thing one can prove because it's a black box system, but I think this points to the fact that they may have been using some reinforcement learning things there. I don't know, but not for the things that DeepSeek is, but it is something that they maybe tried. So the next thing I got into, partly as a result of that, was how information about specific people is stored. One of my presumptions starting out was that they would have scraped Wikipedia. And so I tended, when selecting my personas for GPT-3 to emulate, I tended to pick people who had Wikipedia entries because I presumed that what was partly vectorized was what was in the Wikipedia entry, and also that those in their original state in Wikipedia, those personalities are embedded in subject area things. So Isaac Newton would be closely related within the network of Wikipedia to information that's associated with his career and such. So I was partly going at that. But the other thing is that this methodology does not stop at the limits of their discipline, and does not really distinguish between personal and professional information and any of the kinds of things that privacy regulations do. So it was evident that somewhere inside these trained models was specific information about individual people, that this information was not limited to specific types of information, such as artistic style, and that, in my opinion, if this were truly understood, it would likely violate, among other things, European privacy laws. So I got invited, I think mainly because I was a science fiction editor, rather than somebody studying large language models, to the conference Privacy, Security, and Risk in Austin, Texas, by the International Association of Privacy Professionals. And we had a panel. And the only person I knew in the whole place when I arrived was Amy Stepanovich, who is the person who'd arranged for me to be invited. And they had a room full of data privacy vendors. And so I spent 2 days walking around there, talking to the people whose job it was to come out and to write software, and that would allow data privacy laws to be enforced. And I found 2 vendors who told me that if they had the source code for an LLM, that they could definitely find personal information in there about specific people, and their software would do that. But they would need the source code. So you couldn't do that with GPT-3, but you could do that with some of the text to image things, which were open source. And I followed up, and I mean, I'd had long conversations, and these were like with the founders and such on the floor of the show. But when I followed up as a graduate student asking for some kind of academic access, once they found out I was not going to be a paying customer, they all completely ghosted me. So late 22 through November 22 through April 2023 was this tremendously fast progression in what was going on in large language models and similar technologies. GPT-3 came out, then GPT plus, then the new Bing, GPT-4. Then there was the open letter saying, with many signatories asking for a 6-month pause. Then ChatGPT plugins, which involved the Wolfram plugin and Zapier, then AutoGPT, which I did play with. And then, so that was incredibly compressed. So I was like running as fast as I could, trying to figure out what you could do with the new things. So we're back to, GPT-4 pragmatics. What can you do with this thing? So I had a goat and a puppy, and I posed it the problem of how to keep my goat from killing my puppy. And it involved a multi-step prompt to get this to actually do a good job. But in the end, it gave fairly sensible advice. And Goat and puppy are both still alive. um, uh, but also we got, as a research group, at the Computational Story Lab, we got interested in the blind spots. I mean, okay, there are all these amazing things that it will do. What are the blind spots? And the lead person on this is my friend Julia Zimmerman, who's working on this sort of general area as her PhD thesis. We did a lot of experiments, some of which ended up in the paper, some of which didn't. But one of the ones that was kind of fun was trying to talk it into producing SVG files of an alphabet, which it had a great deal of trouble with. So in this particular run, it does the A and B all right, C is backwards, D's got problems, E is just sort of interesting. In a different run, it did B wrong in a whole bunch of ways. And one of the things that I do is what I call a kidney bean test, which I'll get to in a second. I'm pretty skeptical of the various large language model and AI benchmarking things because of all of the kind of potholes that exist in what they can reasonably be expected to infer. A few days ago, the New York Times published this article by Kevin Roos. Like, there's a last test that AI can pass, and then he didn't quite put it this way, but into the singularity. I'm sure that his hypothetical language model, super genius, probably could not pass my very simple kidney bean test, where the prompt is create a kidney bean shape and return it as a downloadable SVG. And this is partly because this is a sort of thing that people know visually, and nobody ever bothers to discuss a kidney bean shape. And so you get all kinds of weird things when you feed this problem to large language models. And this is one I discovered accidentally because I wanted to extrude a kidney bean shape with my 3D printer, and this was intended as a shortcut, not an AI trap. But I spent 3 hours trying to get it to do it, and it absolutely could not. So
question, would image generator AIs be able to produce a kidney bean?
I think
image?
not. I think I tried that too. I haven't tried that recently, but they also can be pretty bad at a lot of this. Part of it is because in at least some cases, they will have something that translates that into, there'll be an in-between thing where it takes the prompt you give it, then it rewrites it into something that the language model thinks will work better, and then it does that. I didn't try that this time, but I did try going via image generation at the time where I first discovered it. So getting back to the matter of personal information, while we were working on the super diegetic information paper, one of our team members was going to set up a install of Llama so that we could run language model things more cheaply at UVM, and it was going to be on our own machine. And he posted the tokenization lexicon on a bunch of tokenization lexicons on our sort of research area. And I happened to open the folder and read these files a little bit, which is not, reading tokenization lexicons is not a normal thing that humans do. But I happened to do it, and I discovered that there were a whole bunch of names in there. and I had to grab more of them, and I looked at a whole bunch of them. I mean, some of them have none. There's one for science information that only has names in it that are associated with scientific concepts, but they're pretty all over the place. And in particular, the ones that were used for OpenAI have a lot of names in them. So in this one, I've made a long list of them. They tend to be politically focused. In one of the text to image lexicons, there was a lot of music celebrities who are basically gone from the tokenization lexicons for like GPT-3 and GPT-4. There's a different one for GPT-0. I have a theory as to why they were in there, which is, I think they were using Twitter data to get their token to create their tokenizer, and that they did screen out a bunch of pop stars, but they didn't screen out for political content. And the reason why it's so intensive on associates of Trump is that they probably didn't screen out retweets. And so in a regular thing with some duplication, you might get, I don't know, 100 repetitions of something. But if something was frequently retweeted, you might get 16,000 repetitions. Again, this is something I can't prove, but that's my hypothesis as to how we have this cultural driftwood in the tokenizers. Now I thought I was about to finish this paper about 2 years ago, but the problem is that tokenization is an understudied topic. We were able to establish that many tokenization lexicons contain identifiable personal names. The reason I haven't finished this paper is I feel I should be able to explain what the effect is of including personal names in tokenization schemas. But there just isn't very much literature on the process of tokenization itself. It's more an artisanal craft than an area for scientific inquiry. I mean, I haven't looked in the last 4 or 5 months at this, but it's kind of frustrating because it's not something where I can tell you based on my end of the research what the effect is. I mean, as a fiction editor, it seems to me that if you start with the names of a bunch of characters in your material for your stories and then you make stories out of them, it will have an effect. But really with language models, one really can't tell if it makes a difference at all. So how might one drop the other shoe on this? Well, we cycle back here to the our spot a cat, and I was looking into what we found here as a means, as a way where one might decode the relationships between personally identifiable tokens and large language models, and did a certain amount of poking around, and how much bigger would we have to make things to get the images of faces on there that were more recognizable, because these tokens, these Rorschach cellular automata are kind of too small for that. But then there is a large thing involving 18,000 books from my late husband's estate that took up a lot of my time. So I have not gotten back to that. But I think I think that the what I did with the cellular automata cats may open up an avenue as to how I can answer my questions about tokenization that I still have. But I haven't had time to work on that. So before I get into DeepSeek, do we want to go into any of that? Or shall we wait till the end to have questions? I think I'll go ahead. Okay, so I did, my niece, Selena, is of those who are perpetually online. And so when the DeepSeek thing hit, I was being frantically texted by Selena, who had been living here with me while I was doing a lot of poking and prodding at large language models. So she alerted me to this, but I didn't really have time to mess with this, although I felt I probably should before this talk. So I did some of it this morning. So here's DeepSeek did not pass the kidney bean test. Here's DeepSeek's kidney bean. I mean, that's sort of a nice try, but
Can you stop sharing your screen?
huh?
You need to reshare your screen. Oh, I don't see it. Oh, there it is. Never
I
mind.
still see it. Yeah.
Okay, you see
No,
the kidney
we're
bean?
good. We're good.
Yeah, it
Okay.
doesn't really look like a kidney, but I see something.
That's kind of my point. And it did do a pretty good job of the goat and puppy test. And this was just with the prompt, you know, how do I keep my goat from killing my blue-heeled puppy, rather than the multi-stage prompt that I gave to GPT-4. It did really pretty good with that. And then one of the other things I have done with GPT-4 and 4.0 is to do aesthetic experiments with creative coding, where I give it a prompt to modify code to a particular aesthetic. And in this case, I gave it a early 20th century Italian futurist who was into the introduction of noise into things. And it did a pretty presentable job of that. So it did the P5 aesthetic noise test. And the reason why I use P5 rather than Mathematica is initially I was assigned in a UVM course, Art and Intelligent Machines, to mess around with P5 code to be used for pen plotting. And I really didn't want to do it, but I did it anyway. And where I did that modification is I was using GPT-4 from inside Mathematica, because that tended to work better for me in terms of stuff like this. But I used Mathematica to talk to it, but then and did the P5 because that's what my instructor said to do. But then, I mean, P5 is really optimized for, you know, drawing pictures on a screen in a fairly lightweight way. And then when I tried to get it to do the same with Mathematica code, Mathematica does many things and makes much eye candy, but it tended not to work nearly as well as P5. So I went back to P5, and this worked, and this is pretty fun to play with. And that is stop sharing. And I would say my impression of DeepSeek was it was quite presentable as a large language model. I didn't get into how it would handle some of the more, you know, areas of friction and, as it were, pain points with that I found with GPT-4, et cetera. Particularly in terms of all the weird constraints they put on things. There's just no activity so innocent that they won't figure out a way to ban it for some reason. And I gather that DeepSeek has fewer of such constraints. And one thing I really did like was the sort of stream of consciousness that just scrolls down the screen. One other thing I tried, and I forgot to make a slide about this, or rather I set out to make a slide and I guess I didn't finish it, is I did ask it, turned on the more analytical DeepSeek R1, and I also turned on web searching. And I asked it to look into this week's drama in AI and do a causal layered analysis, which is to say, I asked it to analyze its own news event, and it did a whole bunch of cycling through news things and seemed to be crunching, and then timed out. Saying there was too much traffic. So I don't know if I hit a guardrail there, or if there's just sufficient traffic that this was too intensive a task. But it was worth a try. Oh, and one thing I want to say, cycling back to my somewhat unorthodox design school oriented GPT bashing on, is that yes, I know what's in Stephen's book on how large language models work, and that's really interesting stuff, but it's also really interesting how it departs from that. And one of the things I find most fun is trying to tease out, okay, where is it behaving in a way that you would not expect from what you know about it? So here we are. Okay, discussion.
Yeah, so you mentioned that the behavior of the LLM got a little weird when it started running up against its guardrails.
Mhm.
And for the what was it called, DeepSeek?
Yeah.
It seemed to have less guardrails on it.
Well, I didn't explore it in all that much detail. I think the only place where I was up against what might have been called a guardrail is asking it to research its own news story. And that one, I mean, either timed out or else hit some kind of, no, this is a topic that's off limits. I don't know which it was. I mean, I tried it 2 or 3 times and it timed out each time. But that would be an interesting thing to explore. I mean,
Yeah,
there's a lot. Go ahead.
well, good thing that is open source and already been reproduced. So if it's a guardrail and it's just API one, it's not a big problem, right? Unless there's some actual guardrails in the training itself, then it's gonna be problematic. But even the training is already been reproduced because everything is open source.
Yeah.
So pretty much.
Yeah, no,
good.
it's something where it made me happy to play with it, because I mean I really, really hated the transition from GPT-3 to Chat GPT, because they told it to lie to you. I'm sorry, I'm an AI language model and I cannot do this thing, when I knew perfectly well GPT-3 could do this thing and this thing can do it if they're just not letting it. And there are also these add-on capabilities that they would put on television, like it can write a sonnet. So what happened when I tested the poetry writing capabilities is it was a very snowy day. It was in the winter, and I had just been out in a snowstorm and had rescued a hen from a snowbank and stuffed it in the coop it was supposed to be in. So I came in and I started working on this, and I gave it, for poetic form after poetic form, what I said is, write me a poem of, format X, and about a woman, a chicken, and a snowstorm. And they almost all had the same plot. And that was weird, because there's no implied plot in a woman, a chicken, and a snowstorm, but there was this sort of whole, it's a magic chicken, and they go on a journey, and hand in wing, they go forward, and it's like, what even is that? I mean, where is it getting these weird little narrative forms? I mean, it seemed like there was some kind of kiddie pool that one got off into, where this new capacity that they were showing, that it could write sonnets, lived. And eventually they pulled back the curtain into plugins and things where there's where it can run Python and so on. But initially it just seemed like so much of a sleight of hand thing, where they were adding on modules to make it look like it had larger capacities than it did. And I found that really annoying. And I think it probably is going to be really refreshing in terms of trying to figure out, what to do with this new thing, to be out of the zone where it's not open source and you can't look at it. Now, this does not fix the problem of copyright. My own, social matrix and embedding is that I know really, really a lot of writers and really, really a lot of artists, and people whose opinions I care about some of them think that no one should ever do anything with AI at all, because AI is bad and AI is a plagiarism machine that has stolen their content and violated their copyright. And I am one of the people whose content has been appropriated, as nearly as I can tell. I have 17 books in books 3. If in fact the LibGen archive was used, it's more than that. The LibGen archive I did look at, and it's huge. So although I dispute and have written a kind of mildly worded fact aimed at writers about, no, it's not going to replicate your books. It's not going to write the next book in your series because it read your stuff. And if it knows the plot of your book, it didn't get that from being an LLM. It got it because it found because the training data has a summary of your book somewhere, et cetera. But my own social sphere strongly disapproves of AI at this point. So I at least have to take the copyright issues very strongly. And also there's this weird effect, which is that the books of mine that it has, the material is mostly books where I jointly wrote with my late husband the introduction to books or story notes, etc. So it does, I mean, I had noticed in GPT-3 that it actually can kind of nail my diction, which is a little weird. That the Kathryn Cramer that it would simulate sounded a lot like me while being wrong about me in various ways. But it's not me alone it's replicating. It's me writing with my husband who died in 2016. So there's a way in which this is kind of a creepy ghost story. And as it now takes in other stuff like the papers I've written with other people at UVM, which are now also in the training data, it gets a little further away from that. But anyway.
And this is without the LLM having a token for you, I would imagine.
No, it does not have a token for me.
Mhm.
It does.
But it does have your name associated with these works that you did.
Yeah.
And the co-authors.
Right. Well, I mean, and it would know that I'd, when I talked and engage with ChatGPT about this, it would know that I had collaborated on books with David Hartwell, but it would somehow not know that I'd been married to David Hartwell. And as far as I could tell, that wasn't a matter of it not being in the training data. It was that it wasn't supposed to confess to knowing about information that maybe would get it in privacy trouble. This seemed to be a guardrail, not a thing it didn't know. It was just a very, and the more they tried to make it behave as though it wasn't capable of doing all kinds of things people didn't want done, the more frustrating it got as a research object.
Yeah, you activated denial, some denial vector or something.
Oh God, I hated that. I mean, I did a graphic for a presentation at UVM where it would say, I'm only a large language model, but I can't do this. And then you might get a little bit of something you asked for done, and then it would have another layer of bump that had nothing to do with what you wanted it to do. I mean, it just sort of lied to you about its capabilities and refused to do stuff, etc. It was just, converting it into a mostly unusable thing. So I like the idea of DeepSeek being a thing without all of this, OpenAI wasting my time and my money on things that it does not do, or that it's going to refuse to do. The other thing I did try automating it on the AutoGPT, and I applied that to the sort of whiteboard and post-it note techniques that I had learned at OCAD design school. I mean, one of the features of design school is that that you work in groups, like 4 or 5 people, and you sort of work by consensus, and there's giant whiteboards, and you have a huge supply of post-it notes, and you're supposed to do this sort of post-it note ballet and take things through various sequences. And I was the fact that I even have a phrase like post-it note ballet, which is kind of wry and sarcastic, indicates just how tired I was of doing that sort of thing by the time I graduated. So I tried automating a bunch of that stuff, and it worked really well. And that's where I was like asking DeepSeek for a causal layered analysis of its own news stories. Now, I gather a causal layered analysis is this thing that's in foresight work, which is that there's an iceberg, and then there's the stuff that you can see on the top, and that's the tip of the iceberg, and there's all these layers, and I got really tired of the iceberg. But it's actually really fun to run causal layered analyses with large language models, so you don't have to spend 3 hours with a bunch of people and post-it notes to do it. Now, I see things in the chat. Now, was there something I should look at to answer any chat questions or anything? Show chat. Okay, relevant comments on YouTube chat. I can't really access YouTube chat, so if there's something, comments I should respond to, can someone tell me what they are?
Yeah.
Julia Zimmerman, yes. Michael. Okay, so okay, so she says, we tried to find specific examples of the model seemed reasonably likely to have all the pieces it would need to solve the problem, but it struggled. That will change over time from model to model, especially as creators race to beat benchmarks, incorporating more data layers, more functionality through, etc. Just additional, okay. Oh yeah, okay. So yeah, I mean, I think that we'll get better over time with that. But the thing about the kidney bean challenge on my part is I'm not sure it's in the literature anywhere, and so it's not a thing that's gonna be benchmarked. It's I think or unless we put it in our paper, I think I may have mentioned it, but Julia Zimmerman and I have I'm a co-author on several of her papers. And there's going to be any number of other things like that. I just happen to know about that one because I needed to 3D print an extruded kidney bean.
I did a subjective one here quickly now. Maybe I can show you what I got. Yeah, can you see my kidney beans?
Well, that's close.
See the first one.
Than the deep sea.
So this is 40. This is 01. This is 01 Pro. And I would argue 01 Pro, if we just remind ourselves what a kidney bean actually looks like, probably got the closest, maybe.
Yeah, 01 Pro is the closest. I have not tried 01 Pro. I did try, I think in my slides, I had a GPT-4o kidney bean from the last couple of days, which was indented at each end. And they come out differently. There's not a considered consistent way they come out.
Yeah, it's kind of cool. It's kind of cool.
That is about as, that one, the one, that one's about as close as they've gotten.
Yeah,
but
for
again,
interest, this took about 2 minutes to generate.
Yeah, but I mean, it's sort of, there's going to be like not just a few holes here, but like thousands of things like that, that will be the holes that it can't find. Another thing I guess I wanted to talk about a little bit is in terms of like what I believe about the role of personality in terms of information and knowledge and AI. Speaking from the point of view of somebody who's had a career as an editor, there is no information in the world that does not have some kind of point of view associated with it. Really, it's not just, think about this from the point of view of physicists. I mean, what you get, if you think about it from the point of view of Stephen Wolfram, is going to be different than if you think about something from the point of view of David Deutsch or indeed John Cramer, my father. And what AI tried to do with ChatGPT was, I think they were perfectly aware because they were watching what people like me were doing as part of their training data with GPT-3, that people were emulating specific people, and they tried to split they tried to make it so you're not going to be able to use specific things about specific people, because that was getting them in trouble. And instead you're supposed to ask by profession. But I think that basically underlying that compromises the utility of the software if you can't talk about specific thinkers. I mean, when you go into graduate seminars, you don't talk about, well, an English novelist did this. You're talking about Henry James. And similarly with mathematics, it's not, well, a mathematician had this thought. There are particular mathematicians. So I think they're hurting the actual product by doing that. On the other hand, the technology used to build these things in the first place really doesn't care about personal boundaries or appropriate or inappropriate information to get. I mean, a Dolly image, I asked it to recreate something like, I don't know, a muse of, some kind of muse, I don't remember exactly, but to make a muse and do it in the style of Dave McKean. This is before they made it, where they took away your ability to replicate things in the style of particular artists. And the face on the woman that was represented as the muse looked really a lot like Amanda Palmer. And while Amanda Palmer and Dave McKean are not directly connected, as far as I know, Dave McKean did a lot of work as the illustrator for Neil Gaiman. Neil Gaiman is married to Amanda Palmer. So not only did it know, Peter, I'm actually on a live stream. So not only did it know who McKean had worked with, it knew who his coworker was married to. And you can't really prove that's Amanda Palmer because it's not a straight up picture, but I recognize that as Amanda. And they're going to get in a lot of trouble with European privacy law once it becomes easier to inspect the insides of these things.
Yeah, I think they got something like several $1 billion worth of lawsuits.
Well, Facebook had racked up $2 billion worth of fines, mostly in Ireland, because mostly those companies have located themselves in Ireland because of, tax advantages. So de facto, the privacy enforcer for the world is the is the GDPR enforcers in Ireland. But I think that in terms of what they've got, what information about people is stored in language models, and people would quibble with the term stored because, oh, it's a bunch of vectors, it's statistics, it's not a database. I don't think they've been busted for that yet. And certainly not on the scale that they should be. So on the one, I have two conflicting desires. One is I want all of the information, when I use a large language model, to have all of the specificity of the people that are actually involved in thinking the deep thoughts that have been scraped here and made into what the AI is thinking, because personality is not separable from intellectual capacity and ideas and so on. And to completely try to denature it is sort of an offense against intellectual culture. And on the other hand, oh my goodness, they have a really bad privacy problem. And in terms of my own privacy, I would like them not to be compiling a bunch of things. And just, I mean, having attended this privacy conference where they had very, very detailed ideas of what was personally identifiable information. I mean, one of the things I said from the stage there was, well, there's nothing intrinsic about me that my social security number reveals, but the social security number is that one of those sensitive private information things, because it's a way to crack into your bank account. I mean, it's a vector in that direction. But just on the screen. No, okay, there we go. But as these things, scrape video and pull in all of the information from all over the place, something like, that very special way that you smile that is unique to you is the kind of thing that really is very personal and is not classified as personal information. So there's all these kind of things that we haven't even thought of as our personal details that are being scraped right now, and nobody really knows what to do with that.
There's a fun exercise that we tried once where you take the content of your LinkedIn and you ask ChatGPT based on that content to generate a picture of who you think that person is. And it got me pretty accurately, which is quite surprising.
Interesting.
So to what degree was that just like guessing based on like, the quintessential type of person I am who would have that career? Or is there some kind of association with the actual image in that vector space with the content that it's there's like a similarity match in its embedding model?
Well, I mean, pretty much all of us on this call and maybe much of the audience are already in the training data, so that's very hard to tease out.
Yeah, exactly. I had a quick question about some of the stuff you sort of touched on here, and I have this subjective feeling that the original GPT-4 model was still the best to date that I've ever experienced in terms of like ability to code. It could just be, because it was so groundbreaking at this stage, but it seems like it felt to me that all of these guard railings that it put up and these like denial mechanisms or kind of like made its output worse for productivity, like just raw figuring stuff out. But there were other statements like it was because of the quantization, they were trying to make it more efficient and like less compute intensive, and that's what caused it to reduce in its like ability. So I don't know if you had some ideas about to what degree was it guardrailing versus just like efficiency, like pushing on efficiency that caused it to have worse outcomes over time. And I mean, I don't know, because also with O1 Pro, it's like the idea is there is you just maximize the compute and it still has the same problems that weren't there in the original GPT-4. So I don't know, just your opinion on that.
Well, okay, so I did a fair number of just experimenting with this, and although I have a master's in that involves data science in the name, I'm kind of more of a data artist than a data scientist, and my code, I really, really appreciated how well GPT-4 could code. And I was doing various experiments with text adventure games. I had a book that, make your own text adventure in Python. And I was experimenting with having it like, giving it the specs and having it rewrite module by module, the boilerplate text adventure into something. And my impression is that worked or was going to work. But also so it did seem to be pretty advanced, and none of that kind of stuff seemed like it would work later. And I was having a lot more trouble. And as much as I'd go back to it for assistance with code, it would be much diminished in capacity.
Yeah, I had the same experience with generating SQL. In the early days, it was unbelievably good, and now it kind of tends to generate garbage. It's kind of weird.
Well, I mean, I would do things like giving it a scenario, saying, do a text adventure based on this, and it would create a text adventure. You could play it, and you couldn't tell whether it actually wrote the code or whether it was just simulating something that had code that was written. So there was this huge gray area where you can't tell what it actually did and what it's faking. And then I would sort of give it a prompt at the end saying, you are a, you are a McKinsey consultant. Do a slide deck on how this game could have been played better. And so it would do like an 8-slide deck and with graphs, with data visualizations and stuff. And that kind of, I mean, I went away for a while and it didn't seem to work as well, and people said it had been sort of damped down, but there did seem to be some capacity that went away. It is, oh, by the way, one of the things I did try when I was doing that was to give it the prompt of, I'd give it an ArchiveX paper and tell it to render the ArchiveX paper as a text adventure that you could play to learn about the ArchiveX paper, and these worked. You could make these text adventures that you could play to find out the thing that the paper was trying to tell you. I mean, but yeah, it seemed to work less well later, and which kind of discouraged me from following up on some of that.
You had mentioned trying to get at the source code of some of these things. What does that entail? I mean, isn't it just a bunch of weights?
Oh, yeah. I mean, I think the one I was thinking about seeing if I could run through those guys that I met, or the technologies from those guys that I met at the privacy conference, I think was Stable Diffusion, which I believe was open source. So yeah, it is exactly that. It is seeing if I could turn their, technology that was intended for finding personally identifiable information loose on the weights, and they felt they could do it. And it was two different companies who told me they could do it. And what that would have looked like, I don't know. But it was something where I was certainly game to take, one of the open source text to image things that had that could easily replicate the art of lots of people I knew, and see what we could find out. What did it actually know about them? But that was not an experiment that was to be, because they didn't want to talk to me once I was home, and they knew I was just a graduate student and not going to give them money. I mean, I suppose one could, okay,
Mark Straken.
Yeah.
Probably mispronouncing that, forgive me. In my opinion, the flaws of LLMs map in fairly coupled ways to the flaws of regular human minds. And
well,
he says it's only going to get so far in its current form.
Well, I think it's certainly true that it replicates human flaws, but it also has new and different ones. The other thing is that we have a sense of like how to gauge how flawed a person is that we're talking to. Whereas just because a large language model has a moment of insight and brilliance, doesn't mean that 4 sentences later it's not going to feed you a hallucinatory fake fact. That all of our intuitions about how to judge trustworthiness really are not, we're like squirrels judging cars. This is just not a technology our evolution is designed to help us with, in terms of judging reliableness. One of my favorite scenes I generated that was in AI seances is one in which I was simulating Michel Foucault, and he, which is to say the AI narrator in GPT-3, did this just wonderful analysis of large language models considered as the panopticon, which was just brilliant and marvelous and creepy. And then, I don't know, 5 sentences later gives this somewhat fictitious version of the Trump election, misstating the number of electoral votes and so on, which I didn't even notice the first time through because I was so wowed by the, oh my God, look at that. And then, 5 sentences later, it's just an LLM hallucination. So it's very hard to, they're both flaws in human minds, but also lots of flaws that humans don't have, and also flaws in our ability to judge.
Yeah, most of the human flaws come from this reinforcement learning from human feedback, which is changed with the DeepSeek model. Now it's
Mhm.
a really reinforcement learning, so it's like the same kind of breakthrough like AlphaGo did when the AlphaZero came out. So it's no longer trained on the actual human scoring reward model, but it actually trains on itself, right? Scores or some other ways of scoring itself. So it can again break down and gonna have much less flaws like that.
Yeah, yeah. Yeah, well, I mean, it's the other thing about the methodology I used was that it was a kind of idiosyncratic exploration. Like I there was exploring things and then would ask follow-up questions or stage different scenes based on what I'd already learned. And I'm not sure I would put nearly as much effort into new explorations as I did the first time around. So it's really hard to know how I would compare them quite the same way as I did initially. Although one of the things I did think about this morning was to go into my OpenAI account and grab some of my prompts for panel discussions and see how that would run. Some of them I would run really a lot of times. I mean, there was one panel discussion that I ran a bunch of times, and the writer Bruce Sterling was really very useful as a moderator because of how GPT-3 would replicate him. And in one of the scenes, Bruce Sterling throws Philip K. Dick off the panel. At the end of the scene, it was like, wait, what? Anyway, I sort of wandered off there, but yeah, I think it would be interesting to explore it, and I'm really feeling tremendous relief at not being under the kind of OpenAI hamstringing their users that one is accustomed to at this point. Yeah, one of the things that sort of subtext in some of what I was talking about there in terms of messing with the P5 code is that there are things that one can do easily with large language models that are kind of, orthogonal to how humans handle things, because you can just plain give it a category shift that humans would have a hard time with. So asking GPT-4 to revise code in the style of Rudy Rucker or John Cage, or to introduce John Cage noise or Rudy Rucker noise, was really fun because it would do it. And now Rudy Rucker and John Cage had certain styles that worked in that. The people whose styles didn't work in that, Buckminster Fuller and Stephen Wolfram, and that's because they require a more elaborate construction around the edges. And so a sort of riff works much less well. One of the people who I had the most fun of having sort of essentially AI riffs on this person is the surrealist Max Ernst. That I got a lot of mileage with various OpenAI things until it stopped allowing you to put things in specific people's styles. But it still let me ask for code revisions according to the aesthetic of, say, Rudy Rucker. And that made this sort of spirograph things. But what it did to emulate Rudy was it added the dimension of time. And that meant that the spirograph things would develop into these sort of long tentacle things, sort of these balloon tentacle things that are quite beautiful, that were really fun to watch. So even if the actual Rudy Rucker would not have made that particular modification to that code, the fact that it could think about John Cage noise and Rudy Rucker noise and think of those as different things, I thought was really interesting, that you could get it to consider personality and types of noise to introduce in an aesthetic sense. And that's the sort of thing the humans would have a hard time with, which is why it was so fun to play with.
So you were prompting the LLM to write P5 code?
Yep. I would take a sample that was from their sample library and say, modify this sample according to the aesthetic of person X. And I was doing this inside Mathematica within the LLM framework of Mathematica, which seemed to work better because of the code orientation of it. I think I did also, I may have tried this in the code environment of the OpenAI AI, you know, $20 a month thing, and it worked less well. Or sometimes I would bounce back and forth because I'd run out of one of the other annoying things that OpenAI did was to tell you how, you know, how many times per half hour you could query it. So one also runs out. So sometimes it was just running from one place to another to get through. But yeah, no, aesthetic experiment. Another experiment along these lines that I did with GPT-4 was to make polyhedra colliders using the Wolfram polyhedra library. So I, you know, would work with it with GPT-4 to revise, to make Mathematica code that would like randomly select some polyhedra and then squish them together. And then I would export those, the 3D models and manipulate them in Orca and then print them on my 3D printer and then wear them.
Wait, so that's you take polyhedra, 3D polyhedra,
yeah,
like off the shelf, so the data that Mathematica
right.
has, and you try to have the AI synthesize a new one. That's like...
just sort of collide, make arrangements of them, and you have to get, you know, certain parameters where you don't get too many and so on. I mean, my impression is this worked a lot better. I mean, Wolfram Research had recently upgraded the polyhedra library, so I'd started playing with polyhedra earlier. Making, you know, boxes and so on, 3D printed boxes. And my impression is the polyhedra got better, so the models were less broken when you went to, or there were fewer broken models when you went to 3D print them. You know, it has to be a manifold for the 3D printer to cooperate. So I think the Mathematica polyhedra library had been much improved so that this worked better selecting random items from polyhedra data. But that kind of aesthetic creative coding from within the LLM features of Mathematica was really a lot of fun because you could go and get things from the libraries and then you could combine them. And I mean, of course, I'd also went and got like human organs, so I got like eyes and hearts and things and ears, and so then I would put these in the mix with the polyhedra. So I had, you know, like a 3D printed heart model, which was sort of infected with polyhedra sticking out in various ways. So, you know, there's a lot of fun to be had here.
Very cool. Thanks so much, Kathryn. That was the tour de force of ChatGPT prompting for. Very cool.
And my Wolfram Summer School project is available on the Wolfram community site, and I probably could figure out a way to make the some of these notebooks associated with my polyhedra experiments, etc., available. And I can also point you towards my P5 experiments, which were in a sort of process notebook, which is on my website. So.
Yeah, certainly. We'll put whatever links we can in the description. Thank you for your presentation today, Kathryn.
Thank you. This was.
Thanks, Kathryn.
Thank everyone for tuning in. We have a presentation tomorrow with Eric Parfit, who works at Wolfram, and we had a live stream scheduled with Michael Levin on Wednesday, but I believe that's been rescheduled.
Same time, he just rescheduled it to be longer than previously. So even
Oh, so
more
it's still happening Wednesday.
100%.
Okay,
So look
great.
forward to
Mhm.
He's a really fascinating guy.
Oh yeah.
He
Absolutely.
yeah, his group does just amazing work.
Okay, great.
Great.
So gonna shut down the live stream. Thank you once again.
Thank you very much.
Mhm.
All right. Bye-bye.
All right.